Hey everyone, welcome to Bon Science. Today we'll be going over Unit 1, Topic 3 in AP Chemistry, the elemental composition of pure substances. So let's just get straight into it. First things first, you need to know what a pure substance is. And so the definition of a pure substance is just a substance that is made up of only one kind of particle. But it's easier to show through examples. So for AP Chem, you need to know two types. You need to know elements and you need to know compounds. So I'm going to write elements up here because that's the first kind you need to know. And an element is when you have one atom or multiple atoms of the same element. I know that's kind of redundant, but let's just take a look at that. So here I'm drawing a carbon atom. Just one atom of carbon, that's an element, right? Self-explanatory. But also, if you have multiple atoms of carbon, so we'll just say here, multiple atoms of carbon, this is still an element right here because it's still just the same kind of atom, right? They're all the same element, so we will still categorize that as an element even though we have multiple atoms. One little thing you should know is that we do have these things called diatomic elements, which is when you have an element made up of two of the same kind of atom bonded together. So a great example is hydrogen, so I'll draw that right here. You can have hydrogen, which is a diatomic, which is just two hydrogen atoms bonded together. Even though you have two atoms bonded together, this is still an element, don't worry. Your diatomic elements, if you want to memorize them, are going to be hydrogen, nitrogen, carbon, fluorine, chlorine, bromine, and iodine. Okay, so that's just a list that you might want to memorize. It might be helpful, but this is still an element. Now, the next category we need to know is compounds. Compounds are when you have multiple atoms bonded together in fixed proportions. Fixed proportions is key. So for example, let's take a look at CO2, a famous compound. Or actually, let's do H2O, a little easier to draw. So we have, this is H2O, right? This is our oxygen. The two little ones are our hydrogens. This is a compound because you have different types of atoms, right? You have oxygen and hydrogen, but they're bonded in a fixed proportion. Always two hydrogens to one oxygen. And just like with elements, you can have one atom of this, right? So you can have one water like this, or you could have multiple. These are both still just compounds, right? Same thing like with an element, same logic. And with compounds, you need to know this thing called the law of definite proportions, which just says the ratio of masses in a compound will always be the same. So for example, H2O is a really good example of this. The mass of oxygen is around 16 grams. The mass of hydrogen is 1 gram, but we have two hydrogens, right? So we have 2 grams of hydrogen for every 16 grams of oxygen in every water molecule, which is just a ratio of 1 to 8. And this doesn't matter for how many water molecules we have, right? If we have 2 water molecules, we have 4 grams of hydrogen and 32 grams of oxygen, right? But the ratio is to 1 to 8. So that's all the law of definite proportions is saying. Now, the last thing you need to know for this unit is empirical and molecular formulas. So let's take a look at CH4, which is methane, and C2H8, which is ethane. These have different proportions of elements, right? Methane has a 1 to 4 proportion, ethane has a 2 to 8. They're different proportions. But if you're savvy in math, you can tell that 2 to 8 reduces to 1 to 4. So we can reduce 2 to 8, and it can become 1 to 4. So let me do that right here. So it can become 1 to 4, right? And because 2 to 8 can be reduced, that's where you get the empirical formula. So the empirical formula is the formula that lists the lowest ratio of elements. So for methane, CH4, that is already the lowest ratio. 1 to 4 is as low as it gets, it can't be reduced. But for C2H8, ethane, 2 to 8 can be reduced to 1 to 4. So the empirical formula would be CH4 because we can reduce the ratio of carbon and hydrogen and get a lower ratio. And this is our lowest possible ratio, 1 to 4, so we would say this is the empirical formula. So methane and ethane have the same empirical formula, right? They both have the empirical formula of CH4, because that's the lowest ratio, but they have different molecular formulas. Molecular formulas are these original ones that list the normal common ratio, right? So that is an empirical formula. Now you also need to know how to calculate these. This is a little complicated, so I have linked a worksheet below, and I'm going to walk you through an example. So let's look at question number 1. It says that we have 26.4% carbon. So 26.4% carbon, we'll do that. 26.4% carbon. we have 3.3% hydrogen, and we have 70.3% oxygen. 70.3% oxygen. And here I will do oxygen and carbon. First step, when you are given percentages, convert it to grams. So 26.4% becomes 26.4 grams. 3.3% becomes 3.3 grams. 70.3% becomes 70.3 grams. Cool, awesome, simple. Next step, divide by the molar masses. So carbon we would divide by 12, it's the molar mass of the periodic table. Hydrogen we divide by 3 from the periodic table. Oxygen we divide by 16, periodic table. So you're going to divide these, you're going to get some numbers. So for carbon I'm getting 2.2, and I'm just doing this in a calculator. For hydrogen I'm getting 3.3. For oxygen I'm getting 4.4. Next step, divide by the lowest of these numbers. So from all the numbers you just got, divide them all by the smallest one. In this case, that's 2.2. So you will divide by 2.2. Okay? And you do that math, you're going to get 1. You're going to get 1.5, and you're going to get 2. That's just calculator stuff. Okay. The final step is if you get all whole numbers, that's fine, that's your empirical formula. But if you don't get all whole numbers, like we did here, you're gonna multiply until you get the whole numbers for all of these. So because 1.5 isn't a whole number, we can't just go with this, we have to multiply it to get a whole number. And you can multiply 1.5 by 2 to get 3, right? So you multiply all of these by 2. You have to multiply them all by the same thing. So we would multiply 1 by 2, 1.5 by 2, and 2 by 2. And you'll get 2, you'll get 3, and you'll get 4. And so that is your corresponding empirical formula. So the empirical formula would be C2, because we got 2 for carbon. We got 3 for hydrogen, so we would have C2H3. And we got 4 for oxygen, right? So O4. C2H3O4 is our empirical formula. The way I got that, once again, is just by doing this multiplication here. That's the corresponding number. Theoretically, if hydrogen had been like 2 or something, we'd stop there. We wouldn't have to do this last multiplication step. But if you don't get whole numbers, you have to multiply it out until you get it. And that is how you calculate empirical formula. This would be your answer for the empirical formula. Sometimes the AP will just straight up give you the mass instead of a percentage. If they do that, just start with the mass. You can skip the first step. Okay, so now you can calculate empirical formula. The last thing you might be asked to do on the AP is calculate molecular formula. The way you do this is the AP asks us in a specific way. So they'll give you the empirical formula, or you'll find the empirical formula, and then they'll give you the mass of the actual compound. Right? So you can look, the example we just did, the worksheet, it tells us that the molar mass of the actual compound is 91 grams per mole. So this is a lot easier. First, you just get the mass of the empirical formula. So for this example, we have 2 carbons, so that's 24 grams. We have 3 hydrogens, so that's just 3 grams. And we have 4 oxygens, so that's 64 grams. If you put that into a calculator, you get 91 grams. Now you divide the mass of the compound, so that's the molar mass we got, so the 91 that the worksheet gave us, by the mass of the empirical formula. So that's what we just found, the 91 down here. Divide those, and you get a 1. Then you are going to multiply the coefficients on the elements, so these coefficients right here, by the number you just got. So it would be 1 times 2, 1 times 3, and 1 times 4. Obviously, because we're multiplying by 1, it doesn't change anything, and so your molecular formula would still be C2H3O4. But if we had gotten like 2, for example, and it, by the way, it should always be a whole number. You should always get a whole number. If you didn't get a whole number, you did something wrong, go back and redo it. But the number you get, you'll multiply it. So if we had gotten 2, for example, we would do 2 times 2, 2 times 3, and 2 times 4, and we would get C4H6O8, and that would be the molecular formula. So that's all you need to know for the lesson. I know that was a bit longer, sorry, but I hope this was helpful. I'll see you next time.